Does AI truly think? We interact with it daily, but what's happening under the hood? This isn't magic. It's complex computation that mimics understanding. We're pulling back the curtain on how large language models, or LLM, process information and produce seemingly intelligent responses. By the end, you'll grasp the core mechanics that allow AI to think without a biological brain. At its heart, an LLM is a colossal statistical machine. Imagine feeding it an entire library. It learns the relationships between words, phrases, and concepts, identifying patterns and probabilities on an unimaginable scale. This massive data ingestion is the foundation. The architecture is a neural network, a simplified model of our brain's structure with interconnected nodes organized in layers. Data travels through these layers, with each neuron performing a calculation and passing the result to the next. It's like a giant, intricate game of digital telephone. Training involves predicting the next word. If wrong, the network adjusts neuron connections to improve. This process repeats billions, even trillions, of times with the immense dataset. It learns by making millions of educated guesses and correcting mistakes. Some LLMs are trained on hundreds of billions of words more text than a human could read in thousands of lifetimes. This sheer volume allows the model to capture incredibly nuanced linguistic patterns and factual information. When you ask an LLM a question, it doesn't search a database. It processes your input through its trained network and generates the most statistically probable word sequence. It's completing a pattern based on learned information, predicting the most likely continuation. This statistical prediction can lead to hallucinations, confidently incorrect answers. The model might generate plausible, but false information if patterns suggest it's the most likely next word. LLMs don't have feelings, beliefs, or personal experiences. They don't understand joy or sadness. Their output is a sophisticated reflection of their training data, not an internal emotional state. Emergent abilities arise as LLMs grow. They can summarize, translate, write code, and reason through simple problems not because they were programmed, but because these abilities naturally emerge from learned patterns. Like learning a language, LLMs absorb countless examples. They construct new sentences, understand idioms, and create poetry, but digitally and at a massive scale, learning through statistical inference. Model parameters define neuron connection strengths. Larger models have billions or trillions of parameters, granting greater capacity to learn complex patterns and exhibit emergent abilities. Training data is crucial. Biased data leads to biased outputs. Incomplete data limits knowledge. Data quality and diversity directly shape the AI's worldview and capabilities. Interacting with an LLM means engaging a system that has calculated word sequence probabilities from a vast corpus of human text. It's a probabilistic model of language and knowledge designed for coherent output. This statistical pattern matching, at immense scale, creates outputs that feel insightful, creative, and human-like. It's the illusion of understanding born from computation and data. Developers guide this engine using techniques like reinforcement learning from human feedback. This fine-tunes the model using human preferences to shape predictions, making outputs more helpful, harmless, and honest. So, how do LLMs think? They don't. They process, predict, and generate text by replicating complex statistical patterns learned from vast data via neural networks. It's sophisticated pattern matching, yielding remarkable capabilities. Outputs are astonishingly coherent and useful, but remember the mechanism. These models are a testament to data and computation, bridging information and human-like expression without a biological mind. What does this statistical intelligence mean for future creativity and problem-solving? Understanding LLMs means recognizing them as advanced pattern matching systems, not conscious entities. This distinction is critical as we integrate them further. Subscribe to AI Pulse to stay informed.